Hello and welcome to another video. In this video, we're going to talk about MergerFS and Snapraid. MergerFS is a union file system that lets you pull multiple drives into a single mount point. Compared to something like a RAID, MergerFS doesn't calculate any type of parity or any backup, but it has a couple of advantages. The advantages of using something like MergerFS versus RAID is that it's very easy to use. It allows you to use multiple size drives, so you can have a 2 terabyte, a 4 terabyte, and an 8 terabyte and pull them together. So this is very handy. And it also has the advantage that if you lose one drive and you can't rebuild your array, you only lose the data of one drive. You don't lose the data of your whole array. Because in RAID, like let's say RAID 5, if RAID 5 protects you from one drive failure, if while rebuilding the drive, another drive fails, then you can't rebuild your array and then you lose all your data. MergerFS doesn't calculate any parity or any type of backup. But to counter that, we're going to use another software called Snapraid. Now, Snapraid, it's software that only does parity calculation, but it does it on a file system level. It doesn't do it at a block system level like RAID. Now, another cool thing about MergerFS is that you can remove or put new drives into the array without having to rebuild the whole array. So if one day you want to expand your storage, you can just buy a new drive, put it into your computer, add it to the MergerFS pool, add it to your Snapraid, and then that's it. So here I have prepared a demo, and I'm going to show you how to set everything up. The demo that I have set up for you is going to assume that you have at least 3 drives so that we can have 2 drives for data, 1 drive for parity. We're going to use the same VM as before, and we're going to log in with SSH now. I'm going to type in the IP address of the machine, which I believe is 0247. Perfect. Okay, so the first thing that we need to do is we need to create partitions for our drives. So we're going to use lsblk to list our block devices on our Linux VM. And as we can see here, we have our boot drive with all our partitions, and then we have our 3 block devices or hard drives that are 20 gigs each. We're going to use the utility called fdisk. Let's start with the first drive, which is SDB here. So we go fdisk /dev/SDB. So this is an interactive utility. This utility is non-destructive, meaning that all the changes that you do here is not going to affect the drive until you decide to write your changes to the drive. So let's start with creating a single partition. So if we type M for the help file, we're going to choose G to create a new GPT partition table. So we go G and enter. So we have a fresh partition label. Now we're going to press N to create a new partition. Hit enter. Partition number 1, it's fine. First sector, default. Last sector, it's going to use all the drives. That's what we want. If you want to split your drive into multiple partitions, you can also do that. But for this one, I am assuming that you want to use your entire drive. This could be a 2 terabyte, a 4 terabyte drive. In this case, it's just 20 gig virtual drive. So we continue. Okay, so now we have a new partition of the type Linux file system, and up until now, we haven't done anything to the drive, but now we want to write our changes to the drive, so we're gonna press W and then enter. Okay, so if we list our block devices again, lsblk, we can see that now we have a partition here, SDB1, with a size of 20 gigs. We're gonna go ahead and do the same thing for the other drives so that we can have three partitions on our 3 drives. Okay, so we're going to do fdisk. Now it's going to be SDC. Same thing. We press G for new partition table. We press N for new partition. Leave all default. And then press W to write your changes. And now we're going to do the third drive, which is SDD. Same thing. G, new partition table. N for new partition, leave all default, and write your changes to the disk. Now, if we list again, So now we have three partitions: SDB1, SDC1, and SDD1. So now what we're going to do is we're going to put a file system on them. I chose XFS. It's my preference. I like it. It's the default for Rocky and Red Hat, and there's nothing wrong with it. You can use ext4, PTRFS, XFS, anything you want. So let's go ahead and do XFS. To do XFS file system on a partition, we're going to use the utility called MKFS. We're going to do .xfs, and then we're going to give it the path to our partition. So in this case, it's /dev/sdb1, and then just hit enter. Okay, so our file system is created. We're going to do the same thing for the other one, SDC1 and SDD1. If we list our block devices again, there's nothing that changes here, but we now have a file system on these partitions. So now what we need to do is mount these partitions, these file systems in our machine so that we can access them and we can write and read files from them. I'm going to choose the directory /mnt, and we're going to create some folders there. So let's navigate to /mnt. So as we can see, there's no folders here. So we're going to create a couple. We're going to use the utility called mkdir, and it's going to be, just give it a name to our folder, disk1. We create another one, disk2, and we're going to create one that is going to be called parity1. Like a traditional RAID system, you have to sacrifice one or two drives depending on how much protection you want, just to store the parity data. In this case, I'm going to use one drive for parity. So this will be the equivalent of having a traditional RAID 5 on your system. So if we list our folders now, you can see we have disk 1, disk 2, and parity. So now we're going to mount our partitions into these folders. For that, we're going to use the utility mount. We're going to select the partition that we want to mount. So in this case, it's going to be /dev sdb1, and we're going to mount it in disk. We're going to mount it in parity1. So our first drive, SDB1, is going to be our parity drive. Now we're going to mount our second drive, which is /dev SDC1. This is going to be our first data disk. So we're going to mount it into disk 1. And our last disk our last partition is going to be mounted into disk 2. Okay, so if we list our block devices, you see nothing has changed. But now if we list our mount points with df-h, you can see that we have 3 mount points for our 3 drives. Okay, so now that we have our mount points and our drives mounted there so that we can access them and like write files to them and all that good stuff. So now it's time to set up MergerFS. The first thing that we need to do is we need to go to the MergerFS website, or more like their GitHub, and download the RPM installation package so that we can install MergerFS. So we're going to go to our browser and we're going to look for MergerFS. So you can go to their GitHub page. In this case, I am running Rocky Linux 9, so I am looking for the RPM package. If you're running something else like Ubuntu or another distribution of Linux, then you could also follow the steps here to compile it and install it. But luckily for RPM, there's already a package. So I'm going to go to tags and then releases. And as you can see here, we got a nice RPM packages. In this case, there is not a specific package that was built for Enterprise Linux 9 or Rocky Linux 9, but I used Fedora Core 31 and it's working fine. So I'm just going to right click on here and copy link address. I'm going to go to my VM, Let's go to /opt or anywhere you want. And do we have wget installed? No. So we need to install that with dnf install wget so that we can download web packages. Okay. Yes, accept. Okay. Now we can do wget. We paste the link and press enter. Going to go and download that package, and if we make a list here, we can see that we have the MergerFS RPM package here. So I'm going to use DNF just to install it like any other normal RPM package. So DNF install MergerFS. It's going to look for the dependencies. This is a Fuse type of file system, so it's going to install Fuse and Fuse common. That is perfectly fine. Click on yes to install, and that's it. Now we have MergerFS installed on our Linux VM. Now we're going to set up MergerFS. The prerequisites for setting up MergerFS is you need to have your drives partitioned and mounted. We already did that, so we're good to go. So there's two things that we need to set up to make MergerFS work. We need common mount point where we are going to mount all our drives together. We also need to configure our Fstab. So we're going to navigate back to our mount folder or MNT folder. So let's go there. Yes, we have our drives here, and we're going to create a new folder here. This folder, I'm just going to call it storage, but you can call it anywhere, anything you want. This is just the place where all your drives are going to be pulled together. Okay, so now we have our storage folder. That's perfect. Okay, so now that we have our storage folder created, now we need to gather information about our drives and our mount points so that we can set up our fstab file. So what is the fstab file? Basically, this file is very handy because this is the configuration file that the Linux kernel looks at when it's booting up to mount all your drives. So this includes your boot drive, your EFI drive, and your system drive. We want to put in this file all our drives and our MergerFS pooling mount point. So to gather the information of our drives, we're going to just use the ls command, and we're going to list our drives by ID. So what is the ID of a drive? The ID is basically the hardware ID that identifies your drive. And the reason why I like to use this instead of the traditional label that Linux gives to your drive, like SDA, SDB, or SDC, is because if you remove drives or add drives to your system, how the Linux kernel labels your drives is basically how in the order that they are being detected when the system is booting up. Meaning that these labels could change. It happens very rarely, but it has happened before. If the label changes on your drives, then now your SDA drive is the 8 terabyte drive instead of the 4 terabyte. And now you're mounting this drive into the parity mount point, and it's just very messy. What I like to do is I like to use the disk hardware ID instead. So to find out your hardware ID, we're going to use ls, and we're going to go into /dev/disk by ID. And as you can see, there's a lot of stuff here, but we're going to make our lives easier by using a command called grep. Grep is basically just a filtering and searching utility that is very handy to filter out information that we don't need. We're going to use grep. So you just need to type the pipe command here and then grep. And we're going to look for our first drive. Our first drive is SDB1. Well, in this case, we're looking for the partition, not the drive. So SDB1. As you can see, here is the SDB1 partition. So we're going to grab the first one here, ATA VirtualBox hard disk drive. Yours could say something like Seagate or like Western Digital or the brand of your drive, and followed by a couple of serial number or something like that, and part 1. So it's important to use the part 1 so that we use the correct partition. So we're going to copy this one. Okay, so this is going to be our parity 1. Perfect. Now we're going to look for our second drive, which is SDC1. Perfect. We grab our ID here. This is going to be disk 1, and we're going to go and check for SDD1. Same thing. We grab our ID. and this is going to be disk 2. With this information, now we can configure our fstab configuration file. We're going to use vim/etc/fstab. Okay, so this is our configuration file. Now, here is where we're going to determine our mount points and how we want to mount our drives. Let's start by just configuring the mount points of our current drives. Like I said before, we're going to use the ID, so we need to give the full path to our drive. So we're going to grab /dev disk by ID. We press I to insert a new line, and then we paste. So now we're going to grab the ID of our first drive, the parity one. Now we do a space, and then now we need to tell it where we want to mount this partition. Like we said, our first drive is going to be our parity one, so we're going to go and put it on mnt/parity1. Now we need to give the settings and the options that we want for this mount point. So it's very easy. We're just going to copy what we have up here for our root file system. Our file system that we created previously is XFS. If you chose something else like ext4 or btrfs or something like that, here's where you would have to specify what type of file system this is. So in this case, my file system is XFS, so I'm going to put XFS. Now we're going to leave the default settings here and just copy the same thing, 0 and 0. Okay, now we're going to do the same thing with our other two drives. Dev disk by ID, we're going to grab our second drive. I'm going to paste it in there, and then this is going to be /mnt/disk1 XFS defaults. Oh, sorry, here I missed it. Defaults 0 space 0. Now we're going to go and do our third drive. Dev disk by ID, we grab our ID here. /mnt/disk2. Again, this is XFS defaults 0 0. Okay, for the moment we can close our fstab file. So to do that, we just do escape write quit. So WQ enter. And then if we open our drive again, you can see that our changes were saved. Now it's time to set up our MergerFS mount point. So what we're going to paste here is going to be the following. These are the options for MergerFS. We're going to do the same thing. We're going to give it our source. So basically this is the drives, but in this case is the mount points that we want to mount into the pool of MergerFS. So for this, we're going to choose, in this case, /mnt. So /mnt. And here we're going to only use our disk drives. We're not going to use our parity drive because we don't want to store regular files on our parity drive. We only want to store parity information. Because we named all our disks the same way, like disk 1, disk 2, etc. Here we can use a little wildcard to tell MergerFS to use all the mount points that start with disk, the disk name. By putting a star here, we're basically telling the system to use all the mount points that start with disk and whatever follows after. Now we need to choose a destination where we want to mount all these files. So in this case, it's going to be our previously created /mnt storage folder. So /mnt/storage. And now we need to tell it what type of file system we want to use to mount this. So in this case, instead of choosing XFS like we did previously, we're going to choose MergerFS. So in this case, it's going to be fuse.mergerfs. MergerFS. So this is just the way it's the file system MergerFS is named, because MergerFS is a fuse-based file system. So this is how you need to configure it. So now in this part of the configuration file, we're going to give the MergerFS options. Usually just use the defaults, and the defaults work really good for me. And I use one of the MergerFS policies that basically explains whenever you are going to write some information into this mount point. So it's going to choose the drive that has the most amount of free space, and it's going to write the data to that drive. And then if another drive now has more free space, then it's going to use another drive. Basically making it so that your drives get full evenly, and that you're not like filling up one drive and then filling up the next drive and filling up the next drive. We don't want that. Well, at least I prefer that, so that all my drives are getting filled up at the same time evenly. I'm going to paste the configuration file here. You can copy it exactly as it is, or so if you want to learn more about the options and the policies that you can use with MergerFS, you can go back to the GitHub page and go to the README. So this is the link. And if you scroll down here, you can see that there's a description for every single option that we're setting up here. There's also the policies. So if we scroll all the way down here, we're going to see that there's a policy section, policy description. Basically, this is going to explain all the options and the policies that you want to use. So the one that I'm going to be using is MFS. If we look for MFS here we go. It's called most free space. So the description of this is basically just pick the branch with the most available free space. Like I explained before, I want the drives to get full evenly. So now let's set up MergerFS. I'm going to copy the configuration now. I'm going to leave this configuration on the description below so you can just copy paste it. And so I'm going to paste it now. There's a couple of options here that you can see, like cache.files partial, dropcacheonclose. All of these options are described here on the GitHub page. So I will encourage you to go and read a little bit about this. It's really interesting. Like I said before, my current policy is MFS. Let me just make this a little bit bigger so you can see. Okay, so category.create MFS, most free space. Then I have another setting here called minfreespace 10 gigs. And basically what I want is at any given moment in any drive, I want to leave at least 10 gigabytes of free space at the end of the drive. So if one of the drives is getting full, it's just going to stop writing data and leave 10 gigs of free space. This can be changed to maybe like 2 or 5, but this is just a precaution just to make sure that I don't fill the drive 100%. And then the other option that I have here is fsname MergerFS. This is just a label so that I can find it very easily when I do the dh-f command. After that, it's just the defaults like the other drives. And then we're just going to put 0 and 0. That's all the configuration that you need for MergerFS. So we're going to write and quit. Let's clear our terminal. So now if we do df-h, our MergerFS mount point is not there yet. So to mount that, we can use the command mount again. And we're just going to select the mount storage location. So mount storage, we're going to press enter. So it just gives us an error here that says that we need to reload our daemon. We just need to reload the daemon so that it can acknowledge our new changes. But we can do it now, or we can just reboot the machine and it's going to be fine. This is because the Linux kernel is detecting that we changed a system configuration file, but it's perfectly fine. I just did a df-h command again to see if our mount point is up and running. As you can see here, we have our mount storage mount point, and it says that it's MergerFS and it's 40 gigs in size, meaning that it's our two 20 gig drives merged together into one single mount point of 40 gigs. Whenever you're going to write data to this mount point, it's going to choose the drive that has the most free space, and it's just going to continue to fill it like that. So if you write data and it chooses the disk one, then it's going to write to the disk one. And then the next time you write another file, it's going to choose disk 2, because now disk 2 is the one with the most amount of free space. Okay, so this is how you set up MergerFS. It's super easy to use. Like you see now, we just need to create partitions, create file systems, configure our FS, install the RPM package, configure our Fstab, then you have a pooling system up and running. On the next video, I'm going to show you how to set up Snapraid. And Snapraid is going to be your parity and backup solution in case you lose a drive or in case you lose 2 drives. So whatever level of protection you want to go with, I'm going to showcase 2 examples of that. I'm also going to give you a script that you can use to run it every day or every week so that you can automate the process of your backup and your parity calculation. So I hope you enjoyed this video. Leave a like if you like it. Remember to subscribe if you want to see more videos like this, and I'll see you on the next one.